Good morning, respected ma'am. I am Pujita Krishnan and I am pursuing my third year BTech in Electronics and Communication Engineering, Section B. My roll number is 21951A0477. So today I would like to take up the privilege to present my Art Tech Talk presentation on the topic an overview of radomes for large ground-based antennas and the subject antennas and wave propagation. So before we get into a presentation, I would really like to thank my department for giving me this great opportunity as it helped me in gaining a lot of knowledge about this topic and also about the subject and also about how to do the presentation and the slides and all. So thank you once again, ma'am. Uh, so now let's get into our presentation. So what are radomes? So let us start with the introduction. Radomes are protective coverings for large ground-based antennas. Uh, and they are designed to protect antennas from harsh weather conditions and environmental factors. Radomes are help also help to improve the performance and longevity of antennas. So the structures in this picture, this is the structure of the radome. So whatever is the radome that the topic is, this is what the picture is of the radome. So now let's get into our next slide. What are these used for? What is the purpose of radomes? The main purpose of radomes is to provide protection to antennas against weather conditions such as rain, snow, and wind. Radomes also help to reduce wind loading on antennas, which can also improve the stability. Additionally, radomes can provide thermal insulation to antennas, preventing damage from extreme weather conditions and temperature. So this is the purpose and use of the radomes. As we see in this picture, the radomes are used and installed in this way. That is the purposes of the radomes. So now let's know what are the types of radomes. How many types are radomes? So there are mainly two types of radomes, that is solid and mesh type. Solid radomes are made up of solid material such as fiberglass, provide complete coverage for the antenna, and mesh radomes are made of a mesh-like material such as metal or fabric and offer partial coverage for the antennas. As we see in this picture, it is long-lasting material with special coatings. So this is the material which is made, which is used for making radomes, and it is long-lasting material with special kind of coatings, and it is improved. It has one more feature which is improved electromagnetic performance, and it is aerospace level manufacturing and low loss joint lines and 0 to 20 meters in size for custom shapes and 0 to 100 gigahertz frequency range. And ground-based radomes, naval-based radomes, and airborne and defense radomes. So these are the three different types and categories of radomes. So how do we select the material? Material selection for the radomes. This choice of materials for radomes depends on various factors, including cost, performance requirements, and environmental conditions. And common materials used for radomes include fiberglass, composites, and polymers. The selected material should have properties such as high strength, low weight, and resistance to UV radiation. So this is a material selection of radomes. Design consideration. So how do we consider the design for the radome? Radomes must be designed to minimize signal loss and interference with antenna performance. Factors such as shape, size, and thickness of the radome can affect the electromagnetic properties of the antenna. Careful, careful design considerations should be made to ensure that the radome does not introduce significant signal degradation. So this is the design considerations for the radomes. Now we see how is the radomes installed. Usually everyone get doubt how will the radome be installed because it's such a huge kind of structure and it is not easy to install. So now let us see how it is installed. Proper installation of radomes is crucial to ensure their effectiveness. Radomes should be securely attached to the antenna structure to withstand wind and other environmental loads. Installation procedures may vary depending on the type of radome and antenna configuration. Now let's move on to our next slide, that is radome maintenance. Regular maintenance is important to ensure that longevity and performance of radomes. Maintenance activities may include cleaning, inspection for damage or wear, and repair or replacement if necessary. It is also important to monitor the radom's performance over time to detect any degradation in the signal quality. So this is a radome maintenance and how it is maintained. So now let's see what's the radome performance. How does this radomes perform after being installed and installed? Radomes can affect the performance of antennas in terms of signal strength, pattern distortion, and signal loss. The choice of radome material, design, and installation can impact the overall performance of the antenna system. It is crucial to carefully assess the radome's impact on antenna performance during the design and installation process. So now let's see how are the radomes being tested. The radome testing. Radome should undergo testing to ensure their performance meets the required specifications. Testing may include environmental tests such as temperature, humidity, and wind load tests. Electromagnetic tests are also conducted to evaluate the radome's impact on antenna performance. So radome standards. The various industry standards and guidelines exist for radome design, installation, and performance. These standards help ensure that radomes meet the required performance and safety criteria. Compliance with these standards is important for the reliability and effectiveness of radomes. This is the radome standards. So this is the radomes and these are the structures and after being installed and the standards and the quality of the material. So moving on to our next slide. What are the radome applications? Applications of radomes are radome are used in various applications including telecommunication, weather radar systems, satellite communication systems, and military installations. They are particularly important in locations where antennas are exposed to extreme weather conditions. Radomes are also used in urban areas to improve their aesthetics of antenna installation. Cost consideration. So everything should be considered. The cost is important for installing or invention of some item or some object or some new intervention. So the cost of radomes can vary depending on factors such as size, material, and complexity of a design. Solid radomes are generally more expensive than the mesh radomes. The overall cost of radomes should be considered in relation to the value they provide in terms of antenna protection and performance. So these are the cost consideration. Product advancements. So advancement in material manufacturing techniques and design software have improved the performance and durability of radome. New materials and composite offer enhanced strength, weight reduction, and resistance to environmental factors. Advanced design and software allows for more accurate simulations and optimization of radome performance. And now let us look at the challenges of radome. Designing and manufacturing large radomes can pose challenges due to their size, weight, and structural requirements. Maintaining signal integrity while providing sufficient protection can be a deliberate balance. Radomes also need to be designed to withstand environmental factors such as high winds, hail, and extreme temperatures. The future trends of radome. The future of radomes is likely to involve further advancements in materials, manufacturing techniques, and design optimization. Integration of radomes with smart technologies and sensors for real-time monitoring and maintenance is a possibility. Improved understanding of electromagnetic interactions with radome may lead to more efficient designs and better antenna performance. So this is about the radome future trends. So now let's end the topic by giving a proper conclusion, and let's conclude this topic and the overview of it. So what are radomes exactly? Radomes actually play a critical and a vital role in protecting large ground-based antennas from harsh weather conditions and environmental factors. Proper design, material selection, installation, and maintenance are essential to ensure their effectiveness. Ongoing advancements in materials and design techniques will continue to enhance the performance and longevity of radomes. So this is what is the conclusion of the topic of radomes. So that's the end of my presentation, ma'am. Thank you so much for listening to my presentation patiently. I hope you like my presentation, ma'am. Hoping positive feedback from your side, ma'am. Thank you once again for listening to my presentation. Thank you, ma'am.